An alternative to the pack cementation that we use here at Liburdi is the slurry coating method. Slurry coating is done by combining a powdered aluminum alloy with a binder and applying it to the surface of the part. Application of the slurry is typically done by atomized spray. This can be done robotically for consistency or manually for parts that are more specialized and unique. Applications, once the slurry has been applied, the parts are put through a diffusion heat treatment that will drive off the organic binder and cause the aluminum alloy to melt and react with the base alloy to form the aluminide layer. These heat treatments are often harmonized with rejuvenations or other required heat treatment repairs. When you compare slurry coating to the pack cementation, we can see some of the advantages of the slurry. As the slurry application is a room temperature process and the heat treatments can be combined with other repair steps, there's a lower cost associated with it. The different components of the slurry are either driven off in the diffusion process or create the coating, meaning that a lower amount of waste is created and lowering our environmental impact. Some of our LSR processes can also be done using a water-based binder, lowering the environmental impact even further. The slurry itself is very customizable, as variations in the alloy compositions can be included as part of the alloy powder to tailor the coating properties to what we need. Also, because we separate the deposition from the diffusion steps, it can give us a higher amount of quality control, as it allows us to perform checks before the actual diffusion, such as thickness. And finally, the parts themselves are much easier to mask during this deposition. Being easier to mask means that our masking efforts are much more customizable. We can apply coat and no coat areas to the level of precision up to being able to spell words legibly onto a part surface, including our own company name, though this is much less tended to be included in our standard repairs. This also allows us to apply multiple coatings on some parts, such as the 24G vein shown on the left. This part requires the oxidation and hot corrosion resistance on the airfoils provided by the aluminide coating, while the shrouds need the temperature protection of a TBC coating. With the LSR slurry process, we can set up these two different coating methods in a streamlined way to not interfere with one another and to get the best optimization of the part. Additionally, that separation of deposition from diffusion allows us to go back and clean off areas that are difficult or near impossible to mask before or during the deposition, once again allowing us a higher level of precision. Overall, it can allow us to take on more specialized jobs as required. For example, recently we had a set in-house that had a small area around a platform that experienced rub damage. We were able to take those parts, recoat the area without the need for a full repair and without affecting the rest of the part. A common addition to the aluminide coating is platinum. It's often incorporated into aluminide diffusion coatings to improve cyclic oxidation resistance and is often used in components that see a lot of potential hot corrosion damage, such as that LM2500 Row 2 vein as shown before. The platinum dissolves into either a solid solution in the beta aluminide or forms a mixture of platinum aluminide phase with the beta aluminide. So the micro on the left shows the LSR platinum aluminide coating with the light region showing the platinum rich layer of coating. Another typical variation of the aluminide coating is the chromium silicon aluminide, or the Kralsey coat. The added in chromium increases the hot corrosion resistance, while the silicon adds both hot corrosion and cyclic oxidation resistance. Overall, both of these additions lower the critical amount of aluminum needed for proper protection. The other advantage to this coating, it is overall lighter, which means when we apply it, there is minimal weight addition to the blades, which can help with our engine efficiencies. A wide variety of elemental components can be added or substituted to tailor the properties of the coating to the desired effects. While our main additions of platinum, silicon, and chromium are widely used, we are continuously working on developments and continuous improvements to better answer the needs of customers as engine designs and requirements change. One of the helpful things for our process and for our continued developments and improvements is the ability to see our own coating returned to us after service. For example, we first implemented the water-based LSR on parts in 2016, and since then have consistently gotten back the same parts at their next repair cycle and been able to see how they fare under service. This particular blade, the LM1600 LPT, we coated in our water-based LSR back in June of 2016, and the same set returned to us in May of 2022, having undergone approximately 40,000 hours of operation. We were able to see from our analysis that the coating was fully intact, plenty of beta aluminide still remained on there, and no large damages had occurred. Being able to get this active feedback helps us with our process of continuously being able to monitor and improve our LSR slurry.